And the conclusion was, for mirrors that are significantly larger than James Webb, it's not only cheaper to assemble them on orbit, but the risk is lower because you have the opportunity to recover from failures, right? When James Webb goes up, the mirrors have to come out, the solar shield has to pop out, everything has to happen, and you only have one, it either works or it doesn't, right? With robotic assembly, if a part doesn't fit, you get another part, right? Maybe you have to launch it up if you didn't have enough spares, but you have opportunities to recover from failure, in addition to the fact that now you can use smaller launch vehicles to send up parts, and the cost of launch is reduced as well. And if a rocket blows up, which happens about 2% of the time, you haven't lost the whole telescope, you've lost some parts.
All right, we are back with another episode of the Cold Star Project. I am Jason Kanigan, the founder of Cold Star Technologies and your host. I am here with Gordon Roesler. We've just had a little chat about his last name.
Yeah. So the joke is, early in my career as a DARPA Program Manager, we started a program called SUMO, which stood for Spacecraft for the Universal Modification of Orbits, a space tug, one of the things we'll be talking about today. But everybody swears that the reason it had that name was because my last name is pronounced Roesler, Sumo Roesler. But no, that's not the case. But it's in the lore now. It's in Aerospace America, so it must be true.
It must be. So I am super excited to have you on, Gordon, because as you have said, you are a past DARPA program manager. You are a PhD, physics, MIT, very cool, and president of something that I like the name of, Robots in Space. Very easy to understand what that is. It's not a Singletrix or something like that, where you're like,
okay, have to scratch your head about that one. Right?
Or a ridiculous company name like Cold Star Technologies. So we're going to get into what the deal with that is, and I think I'm going to go through. You've provided some wonderful notes here to keep us on track, so I'm just going to go through them. Let's begin with on-orbit servicing, which is something that you are known for, and so robotic servicing of geosynchronous satellites. This is a complex topic, I would imagine. I would be fascinated to get Dr. Marie Bajaj and you in a room together, and maybe you've already been there, and find out, you know, with him and the tracking and you and the actual servicing of it, what can on-orbit servicing do? Let's begin with that.
Sure. So the program that I ran at DARPA and is now being run by my very able successor, Joe Parrish there, had 4 basic missions. The first one is inspecting a satellite very, very closely. A second is to move its orbit, to change it by using the servicer's thruster. A third is to repair things. So every now and then a satellite will have a solar panel that doesn't deploy properly, an antenna that doesn't deploy properly. I mean, recently we had a Eutelsat bird have the solar panel problem. We had a Viasat bird have the antenna problem. And if you have a robot that can push on it, maybe you can fix that. And the fourth thing that we designed it to do was to add things to the outside of satellites, to use a package that was either clamped on or glued on that had some new capability. So those are the basic things. I talk about it in terms of generations. So the first generation of satellite servicing is already in progress. Northrop Grumman has launched its mission extension vehicle, and they're in the process of testing its ability to dock with another satellite and use its propulsion to keep it on station, extending its life. The Intelsat CEO, Steve Spengler, is pretty excited about that. So that's Gen 1 is life extension, which could also be done by refueling. But refueling is much more complicated because now you have to take things apart and attach things and do that sort of thing. So there's 2 ways to do life extension. The second generation of servicing I talk about is these attaching things, repairing things, ultra close inspections where you need the agility of robot arms and you can't do those things without them. So those are the what can it do kind of stuff that we had in mind.
Okay, I'm curious where this is going to go, because my little quick video summary thing, we'll do one probably Monday or maybe later today, where I mentioned that we had this podcast, for example, recording, is called Make Space Boring. And the idea there is not to make it dull, but to make it so normalized that everyone goes, okay, yes, we go to space jobs and that. And so when I think of robotic servicing of satellites. I wonder, can we hire like an ex-Army drone operator or something who's retired to pilot something like this? Or is this going to be completely sort of hands-off thing where I punch commands into a keyboard and a signal goes up and the robot kind of figures it out itself?
So the way RSGS is doing that is every one of its activities is preceded by an automated docking. So one robot arm reaches out and grabs the launch fixture on the other satellite, locks them together so there's no more motion. Everything else can be done by joysticking, right? Because now you've taken the dynamics out of the situation. It's a static stack of two satellites. You can take your time. Plus, automating certain things is difficult because of the geometry is not known a priori. You'd have to write a lot of code. So the paradigm that RSGS is using, and I assume that satellites will use for a long time in the future, is to dock in an automated fashion, because there you're not restricted by time delays, by operator misperception, and then take your time and do the other things with the retired Army drone operator.
Okay, somebody's got to give those guys jobs because they've served and they have an interesting skill set. So I'm looking into the future for that. Okay, so and this really on-orbit servicing comes under the heading, for me anyway, of stuff that you kind of thought would have already been figured out and yet has not, right? And so what's the business case for this? Is there a business case, or is it going to have to be something that government agencies do?
Well, let's look at a couple of aspects of that. First of all, where else in human endeavor do you build something that costs $300 million, $500 million, or $1 billion, and never inspect it again, never maintain it, never upgrade it? So you have to think there's got to be an economic benefit to servicing, right? These extremely expensive, exquisite assets that we just throw away when they run out of gas. Right, so that's the life extension benefit. But then if you launch it and the antenna doesn't come out, it's useless, and so you've wasted all that money. So you've got to think there's an economic benefit there. So on the commercial side, the GEO, and by the way, I'm mainly talking about GEO here because that's where the money is. That's the boardwalk of space monopoly, right? 300 commercial communications satellites. $120 billion a year of bits that go out and come back. I mean, it's a huge market. And if they can manage their fleets more effectively by either extending their life or moving them or letting them run out of gas and disposing of them later, there's money to be made there. On the defense side, there's also very important satellites in GEO, and their servicing comes into play in terms of resiliency and making them more secure and more stable and that kind of thing. So I think that the commercial market's going to pay for the servicing, and then the government can use it as a marginal customer. That's my view.
Okay, and I guess most of these satellites are in a similar orbit range. They're not too high or too low.
At DARPA we picked GEO because that's the money orbit, right? That's where the stuff is. Now there's a lot of energy going into the low Earth orbit satellites right now, constellations of thousands or tens of thousands of satellites. I think Starlink is up to 240 right now, and they're just getting warmed up. So a couple of places where servicing might be applicable in low Earth orbit as opposed to GEO, where most of your listeners obviously know that's 35,000 kilometers up. But if you've got 30,000 satellites in orbit, do you really want to replace that many every few years, or does it make sense to add things to them, to upgrade them on orbit? How does that trade work out? Right. And if some of them die, right, the historical failure rate for satellites like that is about 5%. What happens to those? Do they start banging into your good satellites, right? Can you keep track of them, or do you want something to go up there and dispose of them? So servicing can actually help do that as well.
Right. I really like the idea of picking up the garbage too, because we're going to be throwing all these satellites, these little CubeSats, small sats up there in numbers that we've never done before. The tracking is not really figured out, and there is this assumption that has been made by a lot of people that, oh, they'll just burn up on reentry into the atmosphere when they die. That is not necessarily true. We don't really know what's going to happen there. So a kind of a space garbage truck to go in the low Earth orbit and pick these guys up is probably a good idea.
People are still working on the economics of that, right? So
Mm-hmm.
if I have to send up a robotic satellite, attach it to another satellite, and deorbit that entire stack, that's a very expensive proposition when you're talking about doing that by the thousands, right?
Right.
So can I build something that is very efficient with its propellant or something so it can grab one satellite, give it a push down in the atmosphere, go up and grab the next one, give it a push.
Mm-hmm.
And reusability is going to be a theme that I'm going to come back to a lot.
Right, right. I had a fellow on who was talking about a space forge, and so grabbing old satellites and kicking them up to another orbit, maybe, and recycling them and turning them into something else would be interesting. So,
well, and it would be just about as good for the debris problem, right? You could start agglomerating these dead satellites in one place, so that means it's easier to track, easier to avoid, and then whatever you're going to do with them, let's say aluminum. Right, yeah. Aluminum would be a really good substance to get back out of those. You could do that later, but just the act of sticking them all together, let's say at 2,000 kilometers, where we don't tend to orbit a lot of things, you really have done a good service there.
Right. Yeah, I really like that idea. Who knows when it's going to become economically effective? As long as we're not launching something from the ground to go up there and grab these things every single time. If we can get something up there that can kind of hop up and down a little bit, you know, grab, move, and go back. And I think that would be the biggest cost to avoid. So obviously DARPA is looking into this. Who else is developing this capability?
So yeah, Northrop Grumman developed their mission extension vehicle on their own nickel. Right, so there's one that's in orbit now. The second one's going to be launched middle of the year or something like that. So that was private investment. There are a lot of small companies that are starting to look at space tugs and space servicing now. Some of them are proposing to do relatively simple things like inspection from a few kilometers away. And you might say, well, what's the market for that? The insurance companies are really interested in that, because it's kind of like having an insurance adjuster that can go look at something and say, what's really wrong with that bird? I mean, when Intelsat 29E failed this last summer, it looked like it blew up. I am certain that the satellite manufacturer would love to have some imagery of that to say, oh, I see what went wrong there, and I don't think that exists yet. But that's another private investment kind of thing. NASA is so interested in this whole area that they're creating an organization. It's called the National On-Orbit Servicing, Assembly, and Manufacture Initiative, because they believe that the defense side, the intelligence side, the commercial side, and NASA have common interests in this whole area. And so they're trying to create an organization that all four of those sectors contribute to. They haven't gotten to the point yet where they're actually starting to fund R&D, but I think that's going to come pretty soon.
Right. Well, I can see this conversation starting to happen where we've got people in the room who were in their silos up until recently.
Yep.
In the orbital detection, collision prevention, the math guys, you know, and the satellite manufacturers, the government agencies, and some other actors are finally starting to really talk about this. Correct me if I'm wrong, but I think a lot of it has to do with SpaceX and those constellations, and just an impetus of putting up a lot more things into orbit.
Well, when we started looking at on-orbit servicing back in early 2000s at DARPA, those large LEO constellations weren't really contemplated. Well, that's not true. I mean, you had Iridium was up there, Teledesic, Globalstar, those kind of things. Teledesic, that didn't happen. But that wasn't the debris problem wasn't as big a driver back then. Maybe we just weren't sensitive to it. I mean, it wasn't until 2007 that the Chinese did their destructive ASAT test and created a lot of debris. That kind of made people think, gee, what exactly do we want to be doing here? I think the real driver here is expanding the space economy, right? Making it possible to do more in space primarily to keep up with the demand for communications. I think that's the biggest driver. And on the defense side, the driver is, let's make sure that our satellites are secure because we depend on them so heavily. Who would have thought that GPS, which was designed just to improve weapon delivery accuracy, you know, a real niche-y kind of thing, suddenly became the basis for the global economy. Right? So we have to protect that. We have to make sure that that stays there, that stays secure, robust, and usable by everybody. Otherwise, the economy has a huge problem.
And that is something that I really like about space, is that technologies developed there find their way often into commercial applications, and people end up using them. And they often don't even realize that's the source, that's where they came from. So let's finish up this section with this question. And when will this be real? When will on-orbit servicing of satellites be real? Because it's, you know, technology is being worked out, and maybe it'll be economical, and maybe it won't for a while.
And you know, the question is, I'm surprised that people don't already realize the mission extension vehicle is already on orbit. It's already doing maneuvers next to its first customer satellite, right? The DARPA RSGS satellite will probably be launched in 2022, 2 years from now. So reality is right around the corner. We're not talking science fiction anymore. I mean, you know, 10 years ago, I got that question all the time. Oh, you know, this is smoke and mirrors and that sort of thing. Now we know it's feasible.
Yeah, I don't see it as smoke and mirrors, because we can have a big bomber up there flying along and a refueling plane fly ahead of it, and for a long time they've been, you know, sticking the hose out and refueling in midair, right? If you can do that, it feels like
harder. That's harder.
Grabbing a satellite seems easier. Yeah, that's right. Exactly. So
it's interesting that the environment up there is pristine. Right? So you have a satellite surrounded by absolutely nothing. It's easier than self-driving cars, right? Self-driving cars, you have potholes and pedestrians and stoplights and all that. You don't have that up there. So there are things that make on-orbit servicing technically challenging, but the pristine environment is kind of nice.
Okay, well, let's move to a topic that I am fascinated by, and would really like to get this company involved in: on-orbit assembly and manufacture. I love the idea of making stuff up there, developing some kind of orbital construction platform, and doing asteroid mining and lunar mining, getting all these resources in orbit, saving all the costs. For those of you who are listening or watching who don't follow space that much, it's very, very expensive to kick stuff off of the planet into orbit. Getting out of the atmosphere and the gravity well of Earth is the hardest thing. It's very, very expensive. So if you can grab stuff that's already in space, it's pretty cheap to move around and use up there. So wow. So I'd like to hear a little bit about, I mean, when I have guests on who have been in DARPA or members of the Air Force or something like that, we need to keep away from confidentiality and security issues, right? So I never want anyone to share anything that they can't. But I am curious what kind of projects you have worked on in the past in this area and what your interests are.
Absolutely. The first really challenging and convincing on-orbit assembly experiment is going to happen on a NASA satellite called Restore-L. Restore-L is a servicer in low Earth orbit. Its primary mission is to go to Landsat 7 and put some fuel into it, extend its life. But they're adding a third arm. Very recently, the news came out that Maxar had been selected for this project to add a third arm onto Restore-L and to use it to assemble a large antenna out of small parts. So as we move higher in frequency with our space communications, it gets harder and harder to have antennas that are both large and smooth enough to have good surface figures. So the experiment will be, can I have these tiles, these pieces that are built on Earth and fit together with sufficient precision to improve communications? Larger antennas are good, more bandwidth, higher gain and that sort of thing, but there's a limit to how big a precision antenna can be stuffed into a launch vehicle. So this is a very exciting experiment, because the biggest driver of space right now is communications, both for the geo satellites and the low Earth orbit satellites. And if you can find a way to give them bigger but precise antennas, they're going to be able to continue to maintain their market share in the worldwide communications growth. You know, demand for the internet's growing at 26% a year.
Huh.
How do you keep up with that, right? So everybody's going to, the fiber people, the microwave people, the cellular, everybody's going to be stressed, including the satellite people. But this is a way of starting to tackle that problem of how do I get more throughput from a single satellite.
Okay, and
So
I can
that's an assembly
imagine
one. Yeah.
the vibration of shaking something during launch is also a problem for precision parts. If you could send stuff up in pieces and then assemble it in orbit, you're avoiding any connection issues that are hit by that vibration.
And then, I mean, the next step would be make your entire satellite that way. Send it up in pieces so that you only have to protect the individual pieces from the vibrations and not an entire integrated satellite. That's a real cost saver once we figure out how to do that. That's not trivial.
Once we figure out how to do it. It sounds so simple. Yeah.
You started talking about the use of off-Earth resources, which I think is a coming thing, and it's really important. When the manufacturing that we're looking at right now is simpler than that. It's using Earth-based resources, but launching them as sort of raw materials and then using those to build things in space. A raw material might be a spool of carbon fiber, fiber, and then you build something out of that. The company Tethers Unlimited can take a little box, a 3U CubeSat size box, and spin out a 50-meter long truss just using on-orbit manufacturing. Made in Space has a contract with NASA to build it's about a 40-meter truss that holds solar panels coming out of a box that's only the size of a college dorm refrigerator. So manufacturing, the reason we're interested in manufacturing, even if we haven't harvested the materials off Earth, is just because it uses the volume of the launch vehicle more efficiently, right? To take a really light, thready structure and try to put it in a launch vehicle, it's not efficient. You're not using the launch vehicle very efficiently. So, but once we start harvesting stuff from the moon and from asteroids, then the manufacturing thing gets even more interesting.
Right. Somebody's going to have the guts to take the plunge on that, I think, and create the space, create the opportunity. But then I believe once it gets going, people are going to really latch onto it.
So here's a project that combines assembly and manufacture. Imagine building a big truss out in space, kind of like the space station, but maybe at GEO, putting some solar panels on it. So that's a manufacturing thing. But then sending up payloads that you can plug in to the truss, and the truss is providing your power, your station keeping, your attitude control. So you didn't have to launch a complete satellite. You only had to launch this payload, whether it's scientific payload or a communication payload or a military payload or whatever. And they're all taking advantage of the same truss. So using both assembly and manufacturing, you've created something that's a cost saver, right? Because each of the individual payloads that goes up is less expensive than a fully integrated satellite. NASA's interested in that, DoD is interested in that, and the commercial side is interested in that.
Okay. Now, you've mentioned a couple of companies that are working in this area. What others can we think of?
I know some of the large satellite manufacturers have spent IRAD, internal research and development funds, in order to look at this sort of large truss multi-payload concept. I have some proprietary information on that I won't share, but it's something that's been studied in great detail. Some of the smaller companies, DARPA sponsored some small business innovative research projects in the idea of building one of these platforms. So there were 6 companies, and I don't remember all of them. I know that Tethers Unlimited was one. I think Honeybee Robotics was one. So companies large and small are starting to get into this game.
Right. Yeah, and it's very cool to see stuff happening. And when do you think we'll see something real, something meaty in orbit, let's say?
Well, again, as soon as Restore-L is launched, and it does its primary mission of refueling Landsat 7, then the next thing they'll do will be the assembly demonstration, which is called Spider, I believe is the name of it. So that's a Maxar project. The news came out very recently that they've been selected to do that. Maxar is also the company that's building the robotic arms for both RSGS and Restore-L. So they have that depth of robotic experience that they're going to be putting to use in that Spider demonstration as well. And then the Made in Space manufacturing demo is mid 2020s, but I don't know exactly what the launch date is for that.
Okay, so stuff is coming fairly soon, and that is cool.
Yeah.
You can't afford to be second best. You need to be first, and that requires speed. Now, if you're thinking that growth is supposed to be slow and steady, frankly, the way I was taught back in the 90s in the operations management and business administration programs, you are too slow. We have to adapt. And in space, it's no different than anywhere else. People like to think they're special in space, and it is fun, all the stuff we get to work on, but business is business. The fundamentals nowadays are conservative growth is not good. You need to run as fast as you can and risk outstripping your supply lines, which means in our world, using up the capital that we've got. That's a risk. But there is no prize for second place. There certainly is no prize for third. If you want to scale operationally fast, come talk to us at Cold Star Tech. We are the process experts for scaling fast. Now back to the interview. I am interested in your opinion on Lunar Resources and how those could impact the speed of what's going on here.
You bet. So I think the first use of Lunar Resources is going to be to support the sustainable habitats, right? So ESA is working on the Moon Village idea. China said they want to have a lunar habitat. The United States wants to have a sustainable habitat by 2028. Just getting the water out of the regolith from the poles is going to greatly reduce the cost of doing that. You can use it for drinking water. You can use it for electrolytically decompose it, use the oxygen for breathing, and you can use both the hydrogen and the oxygen from the water as rocket fuel, which is why Blue Moon's Blue Origin's Blue Moon lander has a hydrogen oxygen engine, the BE-7, so that they can make use of those resources. When you do that, then you can imagine taking some of the other resources that you can produce on the moon, metals primarily, from decomposition of the minerals that are there, and launching those into space and using those to create very large structures. The one that's closest to my heart is very large solar power stations in space, beaming power down to Earth at the gigawatt level using microwaves. 100% availability, no greenhouse gases, no radioactive waste, no scarring of the Earth. It's a beautiful vision, and it's very complicated. So there's a lot of work to be done to make that real. But if you care about the climate, it's something that deserves attention and investment.
I am curious. I had a previous guest on the show who talked a little bit about that. Is there any chance that could be used as a weapon? I mean, you are pointing a ray at the Earth.
Well, not if the energy is beamed down as microwave. So if you take a structure that's a kilometer in diameter, so a huge microwave transmitter, in order to make the beam as narrow as possible, by the time that beam hits the Earth, it's about 3 kilometers wide, and the intensity of the radiation is about 1/10 of sunlight.
Okay.
Doesn't sound like a weapon, right?
Yeah.
Now, if you decided to beam the power down by a laser instead, and there's some reasons to do that, but building a laser that's more than, say, a megawatt is a real trick, right? But that, that could be used as a weapon, although not really very effectively, because there's still clouds and so forth and so on. But the microwave concept is, I'll use the word harmless. And as we know, there's no such thing as a truly harmless technology, but raising the intensity of sunlight by 10% doesn't sound like all that big a deal.
Okay. Well, very, very cool. Let's wrap up this section with a question about NASA and NASA's interest in this kind of technology, if at all. And it's funny because I remember before I really decided to get focused on learning about space, I just thought of NASA as launch vehicles, right? Like that's what you see mostly is launches. And then as you learn about it, you find out it's really not a whole lot about what they're about. So what is NASA's interest in on-orbit assembly and manufacture?
So I already talked about the national OSAM initiative that they're starting. So I won't repeat myself, but they're looking at, so what are NASA's big missions? So science, and that includes both earth science and astrophysics and sun science and that sort of thing, and exploration. Right now, the biggest astrophysics project underway is the James Webb Space Telescope. And that's had a lot of problems. And a lot of the problems come from the complexity of it and how to fold it up and squeeze it into a launch vehicle and that sort of thing. So the question was asked a couple of years ago. It was actually asked by the director of the astrophysics division. When does it make sense to build something on orbit rather than trying to put it all together on the ground? So NASA did a large study. It's called the In-Space Assembled Telescope Study. I was one of about, I don't know, 50 or 60 people that worked on it. And the conclusion was, for mirrors that are significantly larger than James Webb, it's not only cheaper to assemble them on orbit, but the risk is lower because you have the opportunity to recover from failures, right? When James Webb goes up, the mirrors have to come out, the solar shield has to pop out, everything has to happen, and you only have one. It either works or it doesn't, right? With robotic assembly, if a part doesn't fit, you get another part, right? Maybe you have to launch it up if you didn't have enough spares, but you have opportunities to recover from failure. In addition to the fact that now you can use smaller launch vehicles to send up parts, and the cost of launch is reduced as well. And if a rocket blows up, which happens about 2% of the time, you haven't lost the whole telescope, you've lost some parts. So NASA's really, the science division, or the science mission directorate, is very interested in this capability for the telescope after James Webb, which hasn't even been selected yet, right? The decadal survey process at the National Academy of Sciences is still in process. But if they were to recommend something really huge for the next big telescope, NASA will take a very serious look at, so how are we going to build that? Are we going to do it James Webb Redux, or are we going to try this whole new method, which would require some technology development, right? Because we never built a telescope in space before. So there would have to be some precursor missions that show that it works. So NASA is extremely interested, is the bottom line here.
Right. Okay. And yeah, and anybody who's interested in the James Webb Telescope can go onto YouTube and do a search for that. You'll find lots and lots of videos. I know Fraser Kane covered it, Scott Manley has covered it, and so lots of YouTuber personalities have had a look at it.
And if they want to understand the in-space approach, the in-space assembly approach, all you have to do is search on exoplanet ISAT, ISAT, exoplanet ISAT, and that report will be the first thing that comes up, and it's available to the public to read, what was our thinking, and what were the assumptions that were made, and what are the processes that would be used, and how does it compare to the traditional. It's all there, and I think it's very interesting reading.
Well, I will go check that out for sure. So let's see, our next topic area here is reusable in-space transportation. I'm sensing a theme here. It goes up and it stays up. We have reusable rockets these days. SpaceX is landing things and reusing them and that, but the idea here, I guess, is it goes up and it stays up. Somehow it gets refueled, it can grab on to other things and move them around from one orbit to another. What's the idea here? And tell us about your personal interest in it.
Sure. So as you mentioned, SpaceX and Blue Origin are both reusing their first stages, right? The second stage has to be re-entered and disintegrated in order that it not become more space junk. And we're not going to get away from second stages, but what we would be able to do, let's say we wanted to send a satellite to geosynchronous orbit, right? So today we have to have enough oomph on the rocket to get it all the way out there, and to get rid of that second stage, usually by putting it out in the graveyard, right? What if we only had to launch that same satellite into low Earth orbit and then have something else take it out, right? And then that something else, that tug, can come back and be refueled and get reused. So again, there's an economic argument to doing this that's very powerful. I mean, we've all run the numbers on these things, and we understand.
Mm-hmm.
You know, if you have to spend $500 million on a tug, but you can use it 20 times, right? Instead of having to buy the more expensive vehicle, you can buy a less expensive vehicle just to get to low Earth orbit. So what's an example would be the difference between a Falcon Heavy and a Falcon 9. A Falcon Heavy can take 7 tons all the way out to GEO, right? A Falcon 9 can take maybe half of that or something. I don't know exactly, but what if instead we just bought that Falcon 9, paid the tug operator $25 million to get us out, but the difference in cost would have been $50 million. It's a complete win-win, right?
Right, and so
that's reusable.
Nice payback schedule chart for that big investment up front.
And now the pitch for robots in space, right? You want that tug to be able to dock with a number of different entities, right? You don't want to force everyone to use the same standardized feature, because they won't, right? Getting spacecraft to all agree on a standardized thing has never worked, right? And rather than counting on that, if you have dexterous, flexible, strong robotic arms on the tug, it can grab large things, small things, and anything in between, and provide that service to a wider range of clients. So that's a key part of making the tug business work, in my view, is to give them those highly adaptable robot arms that can be the coupling device with their customers.
Okay. Would these be primarily chemical fuel, or would you look at electric propulsion?
It would almost have to be electric. Getting something out to GEO and back with chemical propulsion is, it's like a 20-to-1 mass ratio. You're talking about, I can only get 5% of the stuff out there and get myself back. So with electric propulsion, the mass ratios are much more favorable, and it's slower. So there's no free lunch, right? So until we get something that has a lot of power, these are going to be very slow trips going out to GEO and back. The company Ad Astra Rocket has a very powerful electric thruster that they've been working on for many years, Franklin Cheng Diaz. It's a brilliant design, and I think it's very close to moving on to the next level, right, to creating a protoflight unit. So that's the kind of thing that you want to integrate into a tug in order to make the trip faster.
I remember Dr. Joel Sercel has something going on in this area as well. I'll have to look up what the details are.
That's the company Momentus, right? Yeah. Isn't he associated with Momentus, right? So their thruster is a little different. Instead of using an ionized gas, they use extremely hot water that's created by microwaves, right? Same kind of idea. The specific impulse of that, which is a term of art in the space community, is not as high as an electric thruster like at Astra's. Both have their uses. There's times when you want one as opposed to the other, because you can get higher thrust levels with the Momentus, technology, but you need more fuel because its specific impulse isn't as high. Okay. There's a market for both of them.
Now, we just kind of quickly brushed over the business case of spending a big chunk of change up front to have this space tug, and then it gets used and used and used. And every time it pays for itself a little chunk at a time. But what volume do you see, and how long does it take before we get enough going on up there in order to make this viable?
Well, so we launched to GEO, on average 15 satellites a year. And that number is going to go up because of this growth in demand for the internet, right? More and more satellites are going to be providing broadband services like Viasat does, like Intelsat does. So that number of satellites is going to grow slowly. But let's stay at 15 a year, right? The tug, let's say it captures 20, 25%. Let's say it captures captures a quarter of that market. So for a year, it'll pay for itself in about 5 years, right? About 20 launches, and the price that they're going to charge will be amortizing the cost of the tug. So it's really a matter of investor confidence. It's always been true with any technology. Growth doesn't really happen until there's investor confidence. You know, the railroads, it took a long time to get people to invest enough money, but look at how the railroads benefited America. The aviation industry, you know, for a while it was just barnstormers in the US mail. Then all of a sudden, wow, let's have airlines. The same thing is going to be true here. We need the demonstrations that convince the investors that this is safe, that it's reliable, that it's efficient, and that it's useful. And when we convince them of those things, there's plenty of money out there to do this, but you know, getting it into work requires demos that are just now being developed.
Right. It's interesting you bring up the railroad industry, because that does have some features which I see here. So there's going to probably be a lot of little companies, and then 20, 50 years in, a lot of consolidation probably. And what I want to stay away from is government subsidy of the railroads in space, right? We want to stay away from that.
So in my personal view, what government is best at is the high risk stuff, reducing risk that then becomes, you know, more or less commoditized so that other companies can invest in it safely. That's what we did with space robotics, right, at DARPA. We did laboratory work. We developed a space qualified robotic arm. Now with RSGS, there's going to be the first servicer, and a lot of risk in the software, in the mechanics of the arms, in the rendezvous and proximity operations has been reduced by government spending. But a commercial company is also putting their money into that project. It was Maxar, they fell out. Now it's going to be some other company that DARPA has said they're in negotiation with right now. And because they believe in it, right? They wouldn't do that if they didn't see a market. And that's the most exciting thing, is it isn't just government subsidy anymore. So what for a large space tug or something like that, it's going to be the same thing. I hope the government will reduce the risk of the highest risk parts. Look at Elon Musk. Everybody talks about he has a fully commercial operation, which he does. But where did the rocket engine technology come from, right? Where did the software technology come from, and those sort of things? He's inventing some things in-house, like 3D printing of engine components and that sort of thing. But a lot of the stuff was a result of previous government investments.
Right.
So hopefully we continue that partnership.
Right. Okay. Yeah. And economics is a big topic of study for me. I've been studying it for 20 odd years. And there will be expansions and contractions in the market and corrections. And so if we get a buzz of activity going, you know, it'll look great for a while, and then some recession will hit and people will draw back. And so the question will really be, how efficient and effective are these systems that we create to do these jobs?
Also in 2017 and 2018, there were essentially no orders for geosynchronous satellites. Right? Even though we launch 15 a year. So there was this hiatus, and there were a couple of things that had worried the communications operators. One of them is 5G. How do we fit into 5G? Are we putting the right things up there to fit into 5G? Another thing that worried them was the LEO constellations. Are these guys going to eat our lunch and take our market share and that sort of thing? And I think now, you know, the orders are picking back up. People are starting to build new satellites and that sort of thing. So that's a perfect example of the up and down kind of thing. And so anybody that adds to the infrastructure, puts up a reusable space tug or something like that, is going to be subject to those same vagaries, of course, right? I mean, this is the reason that RSGS had to renegotiate with a new commercial partner, because Maxar, receiving no orders for geosatellites for 2-3 years or what sort of thing, simply didn't have the capital to finish the project, right? That's my personal interpretation. I think that's consistent with what they've said in public, but that seems to be a fairly clear picture. This is never going to change. right? No, the stock market has recessions, and all of economics do that.
Right. Yeah, I just
But
want people to understand that they shouldn't be in full-blown eager beaver crazy. Everything's going to be perfect forever, and always expanding. Yes, the trend line is in that direction, but there will be corrections along the way.
the one that hasn't had any bumps in it for a long time, that's been very smooth on a growth curve, is demand for broadband.
Hmm.
It's been over 20% a year for over a decade, with no hiccups in it. And there's a lot of reasons for that. One of them is, developing nations are suddenly saying, hey, we want some of this broadband stuff, right? And people are wanting more Netflix videos, and people are wanting, there's all sorts of reasons that demand has not had any hiccups in it. It's impossible to say there will never be any hiccups, but it's a beautiful trend, and it's one that everybody needs to. I mean, fiber is not the answer to everything. It's certainly not the answer for mobile customers, but it's also, it gets more and more expensive to put in transoceanic cables and all this sort of stuff. So everybody's struggling to keep up with this demand.
Very, very interesting. You have a note here about how does a space tug like this support lunar activities? I have learned a lot about lunar construction in the last 3 months, let's say. My ability to have a deeper level conversation on this topic has expanded quite a bit, thanks to folks that I've talked to and videos that I've watched, presentations that I've watched, the speakers and that. So you have this phrase here, sustainable presence. Having a sustainable presence on the moon, it's not good enough for us to just go there and come back like we did in the 70s, right? And resource utilization. Tell us about how a space tug helps that out, because the moon is a heck of a lot farther away than an orbit around the Earth, right? A geo-orbit.
Yep. So it's the same argument, economic argument, as for, let's say geosynchronous orbit. If you have a reusable tug, you have to get a certain, even if a habitat is sustainable, I'm going to guess there's things that aren't being prepared there, like food. It'll be a while before we can really do lunar agriculture. And so there's going to be a certain supply train going out there, even if it's sustainable. So the question is, do you want to have to expend a rocket each time you do that to get all the way to the moon, or do you just want to send it to, let's say, low Earth orbit and take it the rest away with a tug, have that tug come back, and that sort of thing? The propellant to get to lunar orbit is not that much more than to get to geosynchronous orbit. It's because at geosynchronous orbit, you're almost out of the Earth's gravity well and into the moon's. As a matter of fact, once 20-some years ago, maybe 30-some years ago, there was a satellite that was in a bad orbit and was placed into a good orbit by sending it around the moon, right? So that even though it's a long distance away, it's not a lot of energy away.
All right, and it'll pull some of that off and bring you to the right height.
Yep.
Okay, I like it. When time does not matter, we can get really, really creative.
That's right.
Okay, and also, I mean, I have no evidence of what I'm about to say, but it is a gut feel that a space tug it feels a lot safer than running the whole thing on, say, chemical propellant or something, right? With once it gets up there and you've survived the initial launch to get out of the atmosphere, that second stage is a lot safer, I think.
Well, that's the goal.
Yeah,
that's the goal, right? Reduce the risk of the docking that has to happen to take your payload out. You have to dock it with the tug.
Right.
Get that risk down so that it's negligible, and you do that with really good automation, right? And then it should be safer and certainly more economical than just shooting up a rocket all the way to the moon every time you want to send something up there.
Okay. Now, as the guy running robots in space and promoting this idea and that, I think back to 2014, 2015, when I first realized, okay, I want to look at space here as a serious thing, and I still tiptoed around the edge for years. You and I talked a little bit about that off camera. What I realized back then was, for this kind of thing, or for asteroid mining at such distances outside of easy communication with the Earth, you need good simulation. And so here you are talking about one vehicle not crashing into another. It is kind of a controlled crash, I guess, to like an aircraft landing on an aircraft carrier.
Oh my God, no, not at all.
I hope not. Okay, good. Tell me how it's not.
I've been out there. I've been out there. I was a naval officer.
Yeah.
I've seen that. No, that's not like that.
Okay, so tell me about how it's different from that, and what kind of simulation or sensor capabilities, feedback loops, and that you believe are necessary in your company to be able to execute this kind of maneuver.
So to be fair, robots in space is one person. You're looking at
Okay.
them, and we don't have a product line. Our product line is consulting and advice and that sort of thing. But when you do these things, a typical mission looks like this. The servicing vehicle will come down within a couple of meters of the client, and then an automated process happens where a robot arm or something similar. In the case of the mission extension vehicle, rather than a robot arm, they use a probe that goes into the rocket nozzle of the client, and it gets a grip inside the rocket nozzle. And then it pulls it in and mounts it securely on the face. But these are very slow and gentle approaches, millimeter per second of relative velocity. And you design the propulsion system of the servicer so that it's not, as it slows down, it has to fire its rocket this way. You design them to fire the rockets off axis so that it doesn't blast the client satellite with its own rocket plumes. This stuff has all been worked out. In terms of simulation, an example that I'm very familiar with is the U.S. Naval Research Lab, which a lot of people say, what does the Navy have to do with space? Well, this is a very actually capable and experienced organization that's launched over 100 satellites. So they have built a simulation facility where you can take 2 real satellite simulators of up to a ton apiece and maneuver them just like they were in space with flight-like software, flight-like sensors, real orbit dynamics. So they actually take gravity out of the picture and have shown in hundreds of runs that this can be done extremely safely in different solar lighting, with different types of fixtures that they're going to attach to. So it's given us a lot, the laboratory work has given us a lot of confidence that these kind of things can be done very safely.
Okay. Now, is that just a naval institution that only they and the government have access to, or can you show up with a bag of money and say, hi, I'd like to rent some time?
They've had lots of people rent that facility.
Okay.
NASA's
That's new to
done
me.
it. Some of the Orbital, what used to be called Orbital Sciences, which is now part of Northrop Grumman, has used that facility. So it gets a lot of use. I would say for the next 3 or 4 years, it's going to be pretty much tied up doing RSGS stuff. Both, they're continuing the development of the software as they move toward launch. And then when they're actual clients, I'm going to guess that they'll build a mock-up of the client and run the operation in simulation with the real hardware in order to show that that particular client, that particular mission is going to be successful before they actually fly it.
Okay, very cool. I'll have to go check that out and learn about that as well. So let's finish up with the last topic you've listed here, which is the International Space Station. And I was just kind of laughing to myself because it is called the ISS, and yet I feel like America likes to say this is what we're going to do with it a lot. That seems to be the perception that I have. It's going to be decommissioned. What would you like to do with it?
So I have a totally different idea.
Good.
Which is
okay.
the United States and its partners presumably are going to create a new space station, but it's going to be near the moon.
Okay.
They call it the Gateway, right? And I don't think that there's going to be a budget to operate 2 space stations. So I think at some point the International Space Station, which has the capacity to host humans, will be decommissioned, and the Gateway will be the place where humans spend a certain amount of time in space. But I think that low Earth orbit, which is where ISS is still important. I think there's a lot of things that need to be done there, and we need to maintain a capability. So I've raised the question, well, why don't we put a space station there that doesn't support humans? that has no capacity whatsoever for people, no pressurized volume, no food, no bathrooms, no nothing, staffed entirely, if you will, with robots, right? They don't necessarily look like people. They're not necessarily robonaut, but these are robotic mechanisms that can do many of the things that today get done on ISS. What are some of the things that happen on ISS that don't involve humans? It launches small satellites from the ISS. It hosts instruments that stare down at the Earth and collect data on the Earth and the climate and that sort of thing. Scientific experiments are done. And today, the way those things are all done is we teach the astronauts how to do them and that sort of thing. And there's a big robot arm on the station. It's actually a manipulator, not a robot, that attaches some of these payloads for staring at the Earth and that sort of thing. Many of those things could be done without any human presence. There are also some things that you're not allowed to do on the space station. For example, bringing a satellite up that has an energetic propellant. No, that's unsafe. But if you have a robotic space station, maybe you could do things like that. Maybe you could assemble a satellite out of parts, launch it into space with an energetic propellant in it, and have it go to a far different orbit. Another thing that we need to do is just test robotic activities. Let's prove that these things are useful in space. We also need to prove them on the moon, right? It's clear that to create a sustainable habitat on the moon, we need to have, as a matter of fact, the vice president visited, or was it the NASA administrator, Jim Bridenstine, who visited Langley recently and was looking at the lunar crane, right? So that's a robot, but it's something that's going to be needed to build the shielding to keep people safe on the moon for prolonged periods of time. You need to have robots doing things before the people even get there. So the idea of a station in low Earth orbit is a place where you can test out a lot of space robotics and continue to do many of the useful things that are done on the ISS today. So that's my idea, is not another manned station in LEO. I think humans moving nearer the moon is the right thing to do. But to have a space station staffed with robots that can do many of the things that are done today and do new things.
Right. And for those who aren't familiar, just haven't thought about it, the moon does not have an atmosphere. And so some construction needs to be done to put up radiation shielding and maybe even to stop projectiles from falling on the surface as well. So either holes need to be dug, caverns need to be dug, or a roof needs to be put up. Initially, a spacecraft could do that, but this arm is very important for that. So would you just convert the ISS into a robotic station, or would you build a new one? What would that look like?
I think that the cost of ISS and the way that it's constructed would preclude its being operated solely by robots. In other words, it being turned into an uninhabited station. I have not studied it. I'm going to pass on that question because I just haven't taken a look at it. My mental model was something completely new, but you raised an interesting question. Perhaps I'll go back and take a look at that.
Okay. And so do we have a robotic space station in NASA's plans then?
I have talked to some officials who have, started thinking about the idea. Saying that it's in their plans is probably, it's not something I could vouch for, but I know that it's in the thought process. Let's put it that way.
Okay. Gordon, you have such an interesting background. You have a clear idea of where you'd like to continue to contribute with space here. Who are you looking to connect with, and who would you like to work with?
Right now, I am so busy that the answer might be no one. But no, I mean, I like to be engaged with the U.S. Space community, both on the private sector side and the government side, because I'm hoping to actually be a part of this new NASA OnOrbit Servicing, Assembly, and Manufacture initiative, because it's a national one. I've felt for 15 years that the needs in the intelligence community, the defense community, the commercial side, and NASA for robotics are common, and that a lot of good work can be done there that benefits all four of the sectors. And I am providing some consulting there now, and I hope to do more of that, because that seems to me to be the next important thing to do, is to get more R&D going in the common areas.
Okay, and what is the best way for people to find out more or connect with you? Is there a website or through LinkedIn?
I do have a website. It's robots-in.space. When I found out that .space was a legal domain, I was pretty happy about that.
Awesome.
And I maintain a library on there of documents that help people understand what's been done in space robotics. There's a blog, a news section, and a calendar of upcoming events that are relevant to space robotics. I'm trying to make it mostly useful for students and investors.
Okay.
So it's not so much the detailed professional information that you need to build a space robot, but to get people realizing that this is an exciting new field, and a lot of good's going to come of it.
Awesome. Well, it's been great to have you on. My guest today has been Dr. Gordon Roesler. He is a past DARPA Program Manager and the President of Robots in Space. Thanks for being here.
It was my pleasure. Thank you so much for having me.
Hey, this is Jason Kanigan, the host of the Cold Star Project and the founder of Cold Star Technologies. I've decided to do something new. I've started doing daily update videos on who I met and what I learned the previous day in the space field. And it's a great sort of follow me thing. You can learn what I learn. I'm meeting a heck of a lot of people and learning a lot of things really fast. And the space field is really disparate. There are tons of nooks and crannies to go into and explore, from legal, operational, regulatory, compliance, and gosh, the end customer. Who'd have thought about that, right? So you can sign up for this. If you go to coldstartech.com/MSB, that's short for Make Space Boring, the mission we're on, then you can sign up, and in your email you will get a daily notification that the new video has been posted. I'm also thinking about doing some branded mini courses and summarizing papers as I'm able to. So those will be some goodies that are in there as well. So if you're interested in that, go to coldstartech.com/MSB and join us on the mission to make space boring.